So today I am going to discuss about molar specific heat capacity of water. Generally, molar specific heat capacity means the amount of heat required to raise temperature of a substance of 1 mole of substance by 1 degree Celsius. So molar specific heat we will write as C equals to, we will write Q by N delta. N is number of moles, delta T is change in temperature, Q is amount of heat which you have given, C is molar specific heat capacity. Generally, what is the meaning of molar specific heat capacity? For example, you have a substance of 1 mole, you are raising temperature from 1 degree, some certain degree, for example 14 to 15, 1 degree temperature you are raising. So, for that how much heat energy is given, that is called molar specific heat capacity. So, generally we consider molar specific heat capacity for gases, but here we are talking about water. Water is liquid, right? So, properties of liquid and gases both are different, right? So, here water, the heat energy, generally in gases, if you consider gases, whatever the energy is given, that is utilized according to the first law of thermodynamics. So heat will be given that is utilized to do some work plus change in kinetic energy. You will be able to do some work and change in kinetic energy, but in case of liquids and gases, liquids and solids, this Q will be utilized to increase the temperature, increase the internal energy. Work done will be nearly zero in case of liquids and solids. So now you can write C equals to delta U by N into delta T, as it is for here N is 1 mole and delta T is 1 degree Celsius, so that we can write C equals to delta U. So change in internal energy, right? So molar specific is nothing but change in internal energy. So for example, if you see, if you go to Maxwell's equipartition energy, so according to that, for example, in case of gases, what happens? Generally, according to that what? According to Maxwell's equipartition of energy. So according to that, suppose if monoatomic gas is there, it has the degree of freedom of monoatomic gas is 3. Further, F is 3. According to Maxwell equipartition theorem, equipartition of energy theorem, with each degree of freedom, the energy associated with each degree of freedom is 1 by 2k. So with each degree of freedom, energy associated is half k. Right? So in case of monoatomic gases, energy associated with the gas is, for monoatomic gas, F by 3k. So here F is 3, that implies that energy associated with gas in case of gases is kinetic energy only. So 3 by 2 k. Why? Because monoatomic gas F equals to 3. It is in case of gases. But see, degree of freedom is what? Generally, degree of freedom is how many kinetic energy terms are there in this energy equation. For monoatomic gas, if you take kinetic energy theorem, that will be half mvx square plus half mvy square plus half m vz square. Because if a particle is there, if a gas molecule is there, it can move along x-axis, it can move along y-axis, it can move along z-axis also in equal probability. So that's why there will be three terms. But vibrational kinetic energy we cannot consider in case of gas particles because they are not fixed. They are not oscillating. At room temperature they will not oscillate. If you give energy, they will move. The kinetic energy will increase. But they will not oscillate. They will not vibrate. But in case of liquids or solids, the molecules are fixed. Right? The atoms are fixed. So we should consider the vibrational kinetic energy also. So this is for gases. In case of liquids and solids, vibrational kinetic energy also will be considered. Vibrational kinetic energy also will be considered. So that this kinetic energy term will be these three. Half mvx square plus half mvy square plus half mvz square plus 3 vibrational kinetic energy terms will be there. So now you see in kinetic energy, because of these 3 by 2 kT, because of these 3 by 2 kT. So total kinetic energy will be 3 by 2 kT plus 3 by 2 kT. Total 3 kT. That is for one molecule. For one molecule. But for in one mole, how many molecules are there? I will get to remember. So in one mole, number of molecules are Na. Will be 6.023 into 10 power 23. So therefore, kinetic energy will be Na into 3 kT. This Na into kT will be written as R. Right? 3R. But in hydrogen, in water molecule, we are talking about water. In water molecule, we have 3 atoms. Right? In each atom, we have 3 by 3 RT. So in H2O, 3 atoms are there. That means 3 into 3 RT. So 3 into. That is. So here, kinetic energy is 9 RT. For 1 degree rise, kinetic energy will be 9 R. So this kinetic energy is nothing but the internal energy. So internal energy equals to 9 R. As we discussed before, internal energy is nothing but molar specific heat. Molar specific heat of water is 9 R. Right? Therefore, molar specific heat of water molecule is 9 R. That we have